Alright guys, today we're going to look at ratios and unit rates. Jesse, Will, are you ready? Okay. Alright, for example, in the United States, about 10 out of every 15 people are eligible to vote. Let me rephrase that. 10 out of every 15 people eligible to vote actually are registered to vote. The numbers 10 and 15 form a ratio. So a ratio is a comparison of two quantities by division. And you can write a ratio in three different ways. A ratio is a comparison of two quantities by division. And you can write a ratio in three different ways. For example, arithmetically, using numbers, we said that 10 out of every 15 people eligible to vote are registered voters. So 10, we use the word 2, 15. That's one way to write it. Another way is to use a colon, 10 to 15, and it's read the same way as if you use the word TO, 2, 10 to 15. Or you can write it as division, 10 to 15. Using variables now, we can write it A is to B, A colon B, or A over B. And in this case, obviously, B cannot be 0 because we can never have a denominator of 0. Questions on that so far? The three ways to write it? And even though it looks like a fraction, it's more of a ratio. Because when you think of a fraction is always a part to a whole, right? 2 out of 6 slices of pizza, okay? Or a third of a candy bar, or half of a soccer field. What's different about it as a ratio is that it's a comparison of two different items. Like we were talking about 10 people who are registered out of 15 total eligible people. So do you see how it's two different items? Or we'll compare boys to girls, or tennis shoes to dress shoes in your closet. Even though they're both shoes, you're not taking a part of a whole. Okay, and that might make a little more sense as we go on here. Now, a rate is a type of ratio. A rate is a ratio that compares quantities in different units. A ratio that compares quantities in different units. And a specific type of rate is a unit rate. A unit rate is a rate that has a denominator of 1. For example, rates might include unit costs, gas mileage, speed. Like when you talk of miles per 1 hour, miles per 1 gallon. Does that make sense? Those are unit rates. 2.54 centimeters in 1 inch. That's a rate. 12 inches in 1 foot. That's a rate. When the denominator is 1, that's a specific kind of rate called a unit rate. Do you want to write some examples down? Okay. So for examples of unit rate we said are miles per And I'm going to put 1 gallon, because that's, even when you talk to your folks or you're talking about people miles per gallon, it's always how many miles do you get per 1 gallon. It's not like, well, how many miles do you get per 20 gallons? It's always per 1 gallon. Or miles per 1 hour. Can anybody think of another one? What other ones did I say? Spencer? Yeah, so what'd you say? Like a feet per second? Um, 12 inches per 1 foot, right? Yes. Good. 2.54 centimeters per 1 inch. There, that's a good one. 3 feet per 1 yard. Did I give you some good examples? Okay. And I have a kind of a cool way to convert units that I learned way later in life, but I'll probably teach it to you on Friday. It just makes things, it's a way to set it up to make it a little bit easier. All right, example 1. A survey asks students whether they had after-school jobs. Write each ratio as a fraction in simplest forms. So when they ask to write it as a fraction, that means they want us to use this way, the 10 over 15. Not using the word 2 or the colon, but if they say write it as a fraction, they mean it like with a numerator and denominator. Okay, so another thing to think about is when it says all students surveyed to students without jobs. This is what's going to tell you what goes first. Whatever goes first in the sentence is the number that either goes first or on top. So for here it said all the students surveyed was 100 students, because that was in the total. Students without jobs. So how many do not have a job? 60. Good. So the rate is 100 to 60. And they want that in lowest terms. Temps. 10 to 6. Good. Yep, good. Can go a little bit more. 5 to 3. All right, let's look at all students surveyed. Still 100, but how about now students with jobs? 40. 5 to 2. So the ratio is 5, meaning for all students. So for out of 5 students, 2 of the 5 students have a job. 3 of the students do not have a job. Questions on that one? All right, let's take a look at the back. All right, unit cost. The table shows prices for different packages of index cards. What size has the lowest unit cost? How many of you have you been shopping for groceries with your parents before? Good, most of you raised your hand. Have you ever taken notice? There's a little tag on the shelf underneath of each item. On there, it tells the unit price. So I never paid much attention to that until I started teaching unit price. And what's interesting, like if you go and look at a box of Cheerios, there's a few different size box of Cheerios, and you might look at it and think, oh, that one's really cheap. When you look at it, it might be 23 cents an ounce. And then you look at a bigger box, and it might be 21 cents an ounce. Okay? So what that does for you is it tells you really how much are you paying per ounce of that cereal. So take a look at it. What's also interesting I found is that in the gas station, have any of you seen little Slim Jim? Slim Jim turkey. Thank you. The jerky, I stood by the counter to pay for my gas. They had them 4 for $1, and they were about a 4-inch stick. Okay, it was a pretty good size, but it was 4 for $1, so a quarter a piece, right? So I'm thinking, okay, that's not bad. Well, then they had a longer one for $1. I was like, oh, without even thinking, I'm like, oh, 4 of those must equal that. Well, it was in a long line, so what I did, me being, a math teacher, took 4 of them, laid them side by side. It was a good 3 inches longer than the whole one for $1. So isn't that almost kind of counterintuitive? Because you think, it was, because there's more packaging on the smaller ones, so you think it would cost more money to make the smaller ones, right? But in essence, you were getting more jerky if you bought 4 small ones for $1 than the big one for $1. So be careful. Sometimes it's just the opposite of what you think. Next time you go to the grocery store with your mom, you'll be like, what? Your mom will be wondering what's going on. All right, so if we have 100 cards, we want to know the price over the number of cards. So the price of a 100 pack of note cards is $2.70. All right, so $2.70 divided by 100. Can we do this without using our calculator? Move the decimal 1, 2, 1, 2, right? So if we have $2.70, the price per card it's not 27 cents, but it's 0.027. So almost 3 pennies per card. Okay. All right, what about the 50 card pack? 50 cards for $1.30. $1.30 divided by 50 is 0.026. Interesting. So, right? Interesting, right? Because what if you go to the store and you know you need 100 pack of cards for $2.70, and then you notice next to it on the shelf, if you bought 2 50 packs, what's $1.30 plus $1.30? $2.60, 10 cents cheaper.
Only with gas.
I know. Okay, the pack of 25 cards now was 75 cents. So there you're paying 3 cents a card. So which card pack has the lowest unit cost? The 50 one. Questions on that, how to do that? Feel free to use a calculator on these. You don't have to figure them out in your head. Okay? All right, converting a rate. You want to convert 30 gallons a minute to cups per second. All right, gallons per minute to cups per second. So you want to go from gallons to cups and minutes to seconds. So what we're going to do here is we're going to use conversion factors that convert gallons to cups and a conversion factor that does minutes to seconds. So we start with our 30 gallons over 1 minute. And this is very important, guys. I know some of you will write fractions like this with a kind of a crooked line. When you're doing units, to help you not get confused, try your best to use a good horizontal line. Okay? Thomas?
What do I mean by gallons per minute?
Let's say gas doesn't pump this fast, but let's say like a pump is pumping 30 gallons a minute. Maybe that'd be a fire hydrant. That'd be pretty slow for a fire hydrant, but it pumps out 30 gallons of water in a minute. Okay, and we want to know how many minutes and how many cups is that per second. Okay, so we want to think about it as something a little bit more useful if we're thinking cups or I don't know. Oh, okay. You know, maybe this could be an example of, you know, football teams will have those water things that just continually spit out water for practice. Maybe that could be a rate for this, and they want to know how many cups can it fill up in a second if it's at a rate of 30 gallons per minute. Okay. So what we need to do here is we need to find a conversion to have cups per gallon. Now, we want to use what conversion? What do you think? Cups in a gallon. Can we figure out how many cups are in a gallon?
I remember it was 2 or 4.
Cups. I think, yeah, I think there's 4 cups in a quart. Okay, keep going. 2 pints in a quart, 2 quarts. How many quarts are in a gallon? What? I think I heard it. 16. So we said there's 16 cups in 1 gallon. Okay? So we have 16 cups in 1 gallon. And now, minutes per second. 1 minute is how many seconds? 60. Good. Now this is what's kind of cool, and this is why I said to use horizontal lines. Because you can cross out, if something's the same on the top as the bottom, you can cross it out. So notice how we have the word gallons on top here, and the word gallons on the bottom here, so you cross out the unit of gallons. You have the unit of minute here, you have the unit of minute here, so you can cross out the units of minutes. We're left with cups over seconds, and that's what we want to end up with. C on top and an S on the bottom. So now let's do some canceling here. We know 30 and 60 both have a common factor of 30, so 30 goes in there once, 30 goes in there twice. Now we also know that 2 and 16 have a common factor of 2, so 2 goes into 2 once, 2 goes into 16 8 times. So on the top I have 1 times 8 times 1, which is 8. And what's 1 times 1 times 1? 1. So 30 gallons a minute equals 8 cups per second. All right, let's do an example. Using the data from example 1, write each ratio as a fraction in simplest form. So we want now the students with jobs. Since that's listed first in the sentence, it goes on top. Okay? So flip over your paper. Students with jobs is how many? 40. To all students surveyed, we said was 100. And that can be 2/5. 2 over 5. All right, for B, students without jobs. That's listed first in the English sentence, so that goes on top. How many do not have jobs? 60. How many do have jobs? 40. 3 to 2. Good. Okay. 2 liters of spring water cost $1.98. Find each unit rate. Now this is, you're going to say, well, okay, Miss K, do I put the 2 on the top or do I put the $1.98 on the top? Well, okay, good. You ask yourselves, do I want to know price per liter or liters per liters per dollar? Well, what it says I want to find the unit, right? What unit are we talking about? The liters. So I want to know price per liter. Remember, per means divide, right? So the price is going to go on top. Price per liter. $1.98 divided by 2. $1.98 divided by 2. So 99 cents. Well, we can't put the decimal and the cent sign, right? It's got to be one or the other. So 99 cents per 1 liter. What? Yeah. This one we might not be able to do in our head, and that's fine. Grab your calculator. Do we usually want to know miles? A car goes 425 miles on a gallon of gas, on 12.5 gallons of gas. Do we usually want to know miles per gallon or gallon per mile? Miles per gallon. So your miles is going to go on top, your gallons is going to go on the bottom. So miles is 425, gallons is 12.5. 425 divided by 12.5, 34 mpgs. Hear that in commercials all the time? This car has 32 mpgs. It is pretty good. All right. Number 3. Complete each statement. Quarts per minute to gallons per hour. So let's set up what we want. We're going to start with 3.5 quarts over 1 minute. Okay? And you always times it. Now we want gallons per hour, right? So I'm going to write down over here what our unit is when we're done. So, do I want to end up with minutes at the end? No. So I need a unit factor that's going to have minutes on top and hours on the bottom. Because I want to keep the hours, because that's what I want to end up with, but I need something to, cancel the minutes on the bottom, cancel the minutes on the top. So I know that my minutes has to be on top. So how many minutes in 1 hour? So 60 minutes, 1 hour. Now I want to get rid of quarts, right? Quarts. So if quarts are on top, if I want them to go away, where do I have to put them? Yep, put it on the bottom. And there are 4 quarts in 1 gallon. Now, if you want to put these conversions on like a little sticky note or a note card so they're all in one place in your binder, please feel free to do that. I know some of them are kind of hard to memorize. Now, remember way at the beginning we said a unit rate has a 1 in the denominator? These are still called unit rates. This one does have the 1 in the denominator. This still is a unit. It just has the 1 in the numerator in this case because we needed to flip it that way to get the units to cancel out. Okay. So now my minutes will cancel out with each other. My quarts will cancel out with each other, and I'm left with gallons over hours. And that's what I wanted, gallons over hours. Move it up a little bit for you there. Now let's do the math. 3.5 times 60. Or can I do any canceling to make it a little easier? What can I do some canceling with? The 4 and 60? 4 goes into 4 once. 4 goes into 60 15 times. Yep. So if I have 3.5 times 15, I get 52.5. So it's going to be 52.5 gallons per hour. And the last one, I'm going to do centimeters per second to miles per hour. So we got 12 centimeters over 1 second. And we're going to know that that's going to equal something miles over hours. How about minutes? I'm guessing that's for minutes in an hour. Miles? No, probably miles. Zoom in? Sure. If I can get this to work. Ooh, there we go. Okay, so if I want to convert centimeters to meters. M can stand for a lot of things, right? We just kind of have to figure out what it stands for. This case, I think it stands for meters, because centimeters, miles? Should we do miles?
Let's just do meters.
Meters?
Where was this book made?
Where was this book made?
We're the only people that use miles instead of meters.
Right. I'm guessing it's probably miles, guys, don't you think?
No.
Yeah, we'll do miles.
Why? They usually don't use meters.
But you know what? That's a lot of conversions from centimeters to miles.
Yeah, that's what I'm saying.
Jinx. All right, let's do meters.
Millimeters.
Okay, so we want to go from centimeters to meters. So in order to cross the centimeters out, centimeters has to be on the bottom, and the meters has to be on the top. Because there's a nice 1 unit conversion here that goes from centimeters to meters.
Oh, it was made here. It's in New Jersey.
New Jersey, okay. So, meters and centimeters. What's a nice conversion there, guys? 1 meter is 100 centimeters. Those centimeters will cross out, right? And I'm left with my meters, which is what I want. Now, 1 second, and I want to get to hours. So, seconds have to be on top, correct? Hours have to be on the bottom, so my seconds will cross out. So if there are 60 seconds in a minute, 60 minutes in an hour, 60 times 60 is? Good job. 3,600. Now, I'm left with meters per hour, which is what we want at the end. So 360 seconds in 1 hour. Make sure we put our unit of 1 in there. Is there any canceling I can do to make the multiplication easier? Jack?
No, Ash, just,
This right here?
it's like right on the tip of my tongue.
Right on the tip of your tongue?
100 by 36,
Good.
like simplify that.
So 100 goes into 100 once. 100 goes into 3,600 36 times. So on the bottom I have 1 times 1 times 1. 1 hour. 12 times 36. We can't because they're both on top. If you cancel, and that's a good little reminder, if you want to cancel, 1 has to be on the top, 1 has to be on the bottom. 12 times 36 is 432. Good. So 432 meters per hour. Questions on that?